All right. Hello, friends. Welcome back to the Nexus podcast. I am your host today, Brad Bonavita, head of product at Nexus Labs. This is where we talk about connected buildings and the playbooks behind them. This episode is for energy managers who are focused on lowering energy consumption across their building portfolio, but are working with a limited budget and limited resources. Today's kind of a special episode. We're going to dig into the HVAC sequence optimization playbook, and we're going to see how it holds up against some real programs that real energy managers are running. This matters for energy teams because you're pressured to meet sustainability goals and energy goals, but you're constantly fighting buildings that are drifting from ideal performance. And it doesn't stop there. This is also really important for facility managers who are trying to maintain equipment and keep tenants happy, because we all know that energy optimization and maintenance operations are super interrelated with one another, and those teams are often responsible for both things. A quick note, if you're trying to stay on top of this space without wading through all the vendor noise, we do write a short newsletter. It's called the Connected Buildings Briefing. It comes out every 2 weeks. It's about 5 minutes long, and it tells you what's worth paying attention to. It's read by over 8,000 people. We will put it in the show notes where you can grab it and sign up if you want to. In this episode, I have two guests joining me. I have Gabe Sandoval, who's the Senior Controls and Commissioning Engineer at UCSF Health. How you doing, Gabe? Thanks for joining.
Doing really good. Thank you for having me.
Of course. And our second guest was on your recommendation. We have Patrick Testoni, Director of Energy at University of California, Santa Cruz. How you doing, Patrick?
I'm good. Thanks for having me.
Yeah, and you two know each other from working together at the Santa Cruz campus, right?
Yeah. I worked at UC Santa Cruz for about almost 10 years, and Patrick and I did a lot of work together.
Nice. I'm sure we will get into a lot of that. So, like I mentioned, we're going to get into the HVAC sequence optimization playbook. So, let me start with that at the Nexus, which is our updates and maybe just a little bit of what the format of this podcast is. It was developed off this playbook. This playbook is now published. It's live for anyone to go download for free on our website. We'll have it in the show notes. It's going to be constantly updated because of conversations like this. So, you guys are going to help me with my first iteration probably. But let me start by just quickly how I developed this, because I did use AI to help me, and I don't think this would have been possible without AI. So I'm actually pretty proud of the way it comes together. So what we do is we've been doing content since 2020. We have over 1,000 pieces of content between event recordings. Gabe presented at the last NexusCon, and then we write our blogs, and we have podcasts like this, and we've put that all into a database now that is searchable by Claude. And what I did is I teach Claude what I mean by HVAC sequence optimization, and I train it on exactly what I'm looking for, and then it goes and crawls our 1,000 pieces of content and looks for examples of building owners who've actually done this and how they've done it. When I go through that and I iterate on like what is real and what's BS, I ended up with 92 pieces of content that we've developed that are stories. It's not something we came up with. We're telling the stories of building owners who've done HVAC sequence of optimization and how they've done it. And then with those 92 pieces, I'm able to tag what is being talked about there, whether that's they're sharing metrics that they're seeing in their program. They have lessons learned that others need to avoid. Maybe their organizational structure, or maybe they're talking about pilots. Maybe they're talking about scaled programs. So I've got this big list. It's all sorted through. Then the hard work comes of like developing this outline, and it takes me days to actually write this thing so it's not full of AI hallucination and full of good material. And out comes this document that's how we think people are doing this based on all the building owners we've interviewed over the days. So for this one, I think there was within those 92 pieces of content, there's over 35 building owners or about who are contributed to this playbook. Dollar Tree, Empire State Realty Trust, Microsoft, Amazon, Lockheed Martin, KIPP DC School District, Wendy's, California State, Dominguez Hills, DataBank, Lincoln Property. That's just some, but there's about 36. And then to finish, why I built this playbook is that we're doing a Nexus Cast event. This is our virtual event series on the HVAC sequence optimization playbook on June 17th. So we are building content to support that. We're going to have 5 or 6 different building owners telling case studies there as well. And this is all to bring together the ultimate guide, ultimate guide for anyone who's trying to run HVAC sequence optimization. So that's why we did this. And I'm excited to have both of you because you're going to see if I've got a bunch of BS in here and see what applies and what doesn't apply. But before we dive into that, I just want to give more context to who you guys are and what you guys are doing. So this is supposed to be rapid fire, so we don't get too into the weeds, but people want to know your roles and why you are the experts in this field. So first, let's hear about your portfolios that you were responsible for, square foot, purpose, what the building types are. Gabe, why don't you go first with what your portfolio looks like?
Yeah, so it is a healthcare system. So we primarily focus on hospital, medical office buildings, surgery centers, anything involved in healthcare. So currently we're somewhere between 3 to 4 million square foot. We've been rapidly expanding. We just bought 2 more hospitals. We're absorbing Oakland Hospital. We're building 2 more hospitals, as well as a few MLBs that we have going on. So yeah, anything related to healthcare is my primary focus.
Okay. And Patrick, how about you?
So UC Santa Cruz is a research institution, so it's a variety of building types. So it's about, I think it used to be 2 million square feet. I wouldn't be surprised if it's like 2.5 million square feet. You've got academic buildings, residential, science buildings, labs, clean rooms, BSL labs. So it's a wide variety. So responsibility, my primary responsibility is the state funded side. So we spend a lot of time focusing on the high energy users, which are the labs and the academic buildings. My role varies. So a large subset of this work is related to energy efficiency, which is related to building performance.
Cool. And so you kind of answered my next question, but maybe you'll have some to add. So Gabe, how about you? What outcomes are driving your work as it relates to energy management? So, I know you guys are in California. Sometimes there's state mandates. There's the EUI you could be tracking, sustainability commitments. Like, what's really driving your day-to-day work and your goals?
So I reside within our department. Is the part of its responsibilities is energy utilities, and so the year over year goal we have is 2% reduction in energy usage. So that's part of what drives a lot of our work. We also have the wider goal, which I think is all UC, including UCSC as well. We're under, which is reduce carbon emissions. I think it's like 90% of the 2019. I think Patrick probably knows it by heart. I don't know it as well. But that is also driving a lot of our work to reduce fossil fuel dependency. So we're rapidly switching over to all electric buildings. A lot of our new buildings now are, we have EUI goals that we try to achieve. And so, much of my work is when a building gets turned over, we're also working to try to make sure that building meets those EUI design goals.
Okay. Patrick, did he summarize it well? Is that the same for you?
Well, it's a great summary. We work on very similar roles. So I'm dealing with the campus. So it's kind of like a layered approach. So energy efficiency is like almost always the tier one. Reduce the cleanest energy is the one you don't use. But then it's about fuel switching to cleaner resources, which is electricity. So we've got a movement at UC Santa Cruz and the whole UC system to switch away from fossil fuel burning. So that's a piece of the work. That 2% per year is a UC goal. So Gabe and I are working towards the same goal with different factors because of the space we deal with. There's challenges for both of us in different areas because of the type of space we're dealing with. But that is the goal, and it drives a lot of the work. And that varies over time. The work, interestingly, Gabe and I did 15 years ago is kind of coming even more to the focus again because this smart building performance with technology improvements is kind of been the overarching theme. That's how Gabe and I sat down the first time began working on projects, which at the time were just getting the baseline started. But now with the analytics, what do you do with all the data, right? First thing is, 20 years ago, how do we get the data was the big primary. Now it's like, what do you do with all of it, right? So it's once again back to the simple building performance because it helps with EUI and it has other cascading impacts as well, but that's a driver.
So one point I did, Patrick, you were talking about how the work kind of differs in the way that you guys have different portfolios. And one thing that I want to caveat with this playbook that made it really hard to write is that as you switch verticals and switch, building types, what people are doing for optimization changes drastically. So it was hard to write this in a way that's universal and helpful for a lot of people because for example, Dollar Tree is talking at our upcoming Nexus Cast event, and they've got such a different challenge with 9,000 plus tiny little buildings that are all the same versus a campus where everything's centralized, but maybe the buildings are a lot complex. So we're going to try to cover all those, and I imagine that you guys are going to raise your hand a couple times and say this doesn't apply, and my counter argument is going to be, yeah, it doesn't apply to you, but it applies to others. But we'll see. So okay, we're gonna kick it off and dive into this. And again, what I'm asking from you guys is like, you can raise your hand, you can just interrupt me, but challenge me or agree with me or give me some anecdotes of where you've seen this apply or how you guys have applied this as we go through. So I do have a set of steps that we'll go through, but before we have to like set the guardrails of what is HVAC optimization. Anyone could probably define it differently. The definition that I wrote down is making continuous optimization of the HVAC equipment you already have, a normal part of building operations. Notice I say the words equipment you already have because I'm trying to stay away from the conversation of capital improvements where it's like, of course, I could have an old chiller and put in a much more efficient chiller and save energy there. And I'm also not trying to dive too far into demand management and flexibility, which I know we could probably do a whole nother episode on with you guys in terms of how your utilities work, how you're understanding what's coming from the grid, what the price of that is, peak demand, all those things, and how you're managing that. But we're not really talking about responding to the grid as much as just how can I optimize the stuff that's already in my building. So I have this graphic that I can put in the show notes. Maybe this will be the first thing that I would like to see if it resonates with you guys. But to describe it to the audience, if you're not looking at it, I think of HVAC sequence optimization. I have three columns here. First, there's the three S's. These are the levers that you can actually use to optimize. So there's the sequences actually written in your building automation system, the logic. You can change those. There's the set points, so you can broaden your set points so you're not heating or cooling as much or anything like that. And then there's the schedules. When are you actually going to run? And the three ways that you save with those three S's are number one, you run less when you don't need to. That's kind of the scheduled part. Are you heating and cooling buildings when you don't need to? Number two, you lower intensity when you can. So maybe you're at partial load, and this is the gift of the variable frequency drive, right? Is that we don't have to potentially run as much. And then number three is you run more efficiently when you do run. There's a lot of ways to interpret that one. The example I thought of is I heard of a recent portfolio that had multiple steam boilers, and they changed the way that they were operating them to stage them more effectively. So you could call that a sequence change too, but staging your equipment to run it as well as possible. And then the two ways to execute, and then I want to hear you guys comment on this graphic, is that the most common way is kind of just like manually, right? You're going to actually have somebody, whether that's an internal or external stakeholder, and they're going to go in and change these sequences and set points and schedules to optimize. And then the other way, which maybe we'll dive into a little later, maybe you guys have some comments on it now, is what we call advanced supervisory control, where you actually have an algorithm, a technology overlay that's going to go in and autonomously change set points, call it every 5 minutes on a discharge chiller or discharge rooftop temperature sensor so set point so that you can get as much optimization all the time. Do you guys buy into these ground rules of where we're starting? Does this like resonate with the work you're doing?
I mean, I can speak first. I mean, it does. Yeah, definitely. I highly agree that those three, the sequence and set points schedules are the key elements. I think if I was to prioritize it, though, I think that would be key to it as well, because if I'm looking at those three, and if I was to recommend to somebody, how are you going to optimize your building and your systems, schedules would be number one. That is to me the number one energy leakage. It happens the easiest, the quickest. It just takes one building operator to go in and change the start time because he feels like it's not warming up or cooling down, fast enough during the day, and he moves it up 2 hours, and all of a sudden you're running 2 hours more than you need to. So I think to me, scheduling is like top priority. I would just list it in that order, and set points and then sequences. Sequences is always a little more challenging because then you're getting into programming and
Sure.
understanding the code. So that gets a little bit more difficult to pull off. So again, if I was putting this out to recommend just for the general energy manager out there, I think that's the priority that I would probably focus in on to help them to make the decisions and what to look for.
Mm-hmm. Yeah, that
Yeah, I
makes
agree.
sense.
The one when you brought this up, I started thinking about all these things that can be encompassed in the three. But the one thing that we find in our phase of work is, I mean, the sparks, right? The equipment that's the sensors and the equipments that aren't functioning correctly, and how they can drive a system out of control. And there's two things we work on, which is how can we identify quicker those failures, right? Because even with the best sequence and the right set points and the right schedules, if you have a bad sensor or piece of equipment, it can um, short circuit, right?
Yep.
And that's what we found. And so there's two ways we address it, which is simplification, which is kind of sequences, right? Gabe, I'm sure you still do with it. You have Rev 1, 1.3, building gets changed 1.5, 1.55. And you have, when you go in there, sometimes you just need to simplify and overhaul sequence operation. Um, and that's been a challenge in the industry too. These new buildings are so complicated, they actually end up burning more energy because they're more volatile to flip on the other side of energy performance. So I think that's known now, but in practice, and it's related to sequences, but I think um, what I'm finding in our early phase of this is just how do we address the maintenance and identification of systems that have equipment that's not performing correctly. So I don't know how you fall that in, but it's a huge one.
Yeah.
Sometimes it means you just limit the control points you have, right? And then you can only have to focus on those points as the high priority ones to watch. But
Yeah, I'm glad you brought that up here because there's a real gray area between what we're trying to put in this box called sequence optimization and what we talked about in our last virtual event, which was what we called condition-based maintenance, and this like overlap between the two. Because what I'm hearing you say is like you can get these signals that something's not working right and respond to that, and often that's in terms of occupant experience or operational efficiency, but that goes so hand in hand with energy, I would imagine. Like you guys, I want you to answer this, but it seems like those things wouldn't really even be that different to someone in your position, because if you're improving operational efficiency, you're probably saving energy at the same time. I mean, do you think of those separate, or are they just
lower
overlapping that well?
maintenance costs, lower
Yeah.
operational costs. The one thing I'm looking right now is before it was basically do it now, right? When it fails, we replace it. And then now it's these planned maintenance cycles, which are fixed and work very good. But with this new technology, my whole thing is like we don't need more labor to modernize. Maybe we should have modernize how we maintain equipment on demand-based maintenance, right? How
Hmm.
can we shift because it results in maintenance improvements, and there's a lot of inefficiency in maintenance in my perspective. I'd love your Gabe's feedback on it as well. I think there's an opportunity to improve maintenance efficiency to support this work.
Yeah. And then Gabe, a question on yours. You brought up the schedules as kind of like the good starting point, which I think is good feedback. Are you in your head? Were you thinking just simply like getting a hold of your schedules and where they're where they're actually overridden or where they land, or were you thinking all the way into like using occupancy as a proxy to understand when you should be running your buildings?
I mean, I think it's like, I think like early in your playbook, you mentioned about drift. And, you have a building that you get day one and it has, and generally when a building's day one, you have a set time you're expected to operate and you base your energy and utility usage off of that. And I think that's what I'm focusing on. Why, if we have to deviate from that, what are the reasons why we're deviating? And
Yeah.
so that's where you get into looking at occupancy of the building and what it's being used for and has it changed and are people overriding things? It can get a little bit, I mean, even though schedules can be simple, it can get a little bit difficult to kind of pin down, what's happening in a building and why is it that we're now running so many more hours during the week than we anticipated and our utility bills are much higher. So it's not as easy as just looking at occupancy, but it is one key element of it though.
Yeah. Yeah. That's a good segue into. I need to get us to the steps, but the second part of the playbook that we wrote is why owners are actually care about this, and I think we've covered a decent amount of that. But Gabe, you talked about drift, and in the intro to the playbook, we talk about we give this scenario where like a building is commissioned and it's running optimally, and then every day you drift away from that of like somebody commands a sensor, and then oh there's an after work event, so there's a schedule, and oh I don't know why that building is over or that set point's overridden, so I'm not touching it, and all of a sudden you're 2 years out and you're very much not optimized. That's the drift we're talking about, but really that's just a that's something that you're fighting that drift so that you can reduce energy consumption. You can reduce tenant complaints, which we were just talking about how that's so related to energy usage, and then sustainability and compliance as well. So I want to hear if you guys have any comments on why people are running this. But one other point is, Gabe, when I was writing that part, I was thinking about your presentation at NexusCon, because I start with when the building is commissioned, it's running optimized. And I could just picture you disagreeing with that, because your whole NexusCon presentation was how about when the construction team walks out, it's actually still not even optimized. So I'm kind of going in with this assumption that we're starting with an optimized building, but I know you talked a lot about that's not exactly how the turnover from construction typically happens.
Yeah, you're reading my mind. I thought I thought about the same thing too when you wrote it. I'm like, yeah, that doesn't happen too often in a building's at 100%. But I think it is. I was thinking about this and how it is good though for energy managers and people running the building, that if you take on a building, don't ever assume that the building ever was running at 100%. And I find that happens many times that I walk into a building that we've taken over. I start digging into the sequences, programming, controls, and I find, yeah, this reset never worked. These points never worked. This never worked. This has been disabled from day one. So I think it is a good lesson to learn that never to expect it to be at 100%. Although ideally it would be nice, but
Yep.
yeah.
Yep. Okay, so I got to keep us moving or else I'm never going to get through this. So I'm going to dive into the actual steps now. The playbook has, I don't even remember off the top of my head. The playbook has 12 steps that we wrote. And we kind of split it into 3 phases. There's the setup phase, the pilot phase, and then the rollout phase. For you guys, you guys are both running pretty mature projects. So I'm going to say things like pilot. I don't really know if that applies super well to where you're at right now, because you've done so much optimization. That the term pilot in this case more applies to the building owner who, like, they haven't even thought about optimization. And so they're going to want to start with like testing something and seeing if how that works and then expand on. So we can dive into that. But first, let's start at the setup phase. The first step is defining your outcomes. We already talked about that. You guys both mentioned, what's driving you, this 2% reduction yearly. Energy prices are obviously increasing. Sustainability goals. As a building owner, you got to kind of determine what outcomes you're actually driving for. But the next one I want to talk about is number 2, confirming your energy management hierarchy of needs position, which is a mouthful. And we have another graphic here that we'll share. But the idea here is really like, you can't just go into a building and start optimizing right away if you don't have some foundational building blocks that are going to allow you to do that effectively. Do you need all the building blocks? No, but you're going to need some of these to be effective. And these building blocks in this pyramid are things like utility data analytics. So do you understand what you're spending on your utility bill? Interval meter analytics. Do you have sub-meters that can actually tell you what your worst energy users are? Automation and digital control. If you can't actually digitally change a set point, you're never going to succeed. Centralizing data. If you don't have data in a place that you can access it. So those are, like, I would say, probably the 4 biggest building blocks. Then on top of that, you can do these manual optimization things like retro commissioning all the way up to advanced supervisory control. So I would love for you guys to comment on the pyramid. I think my question for you is, are you guys evaluating like a building by building in a similar lens? Because I imagine that there's all these different maturity levels of how far along each of your buildings are. So is this pyramid a different game for every building in your portfolio that you're playing over and over? Patrick, what do you think?
So to clarify, it builds from the base up.
Yeah. So the base is like, these are the blocks that you need. And then the top is like, if you had those blocks, you can do these other things.
No, it looks pretty good. I mean, definitely whenever we're looking at buildings, we look for the building level up because that's where you have most of your data. Some people don't, but building level data is monthly data, then getting 15-minute data. That helps you evaluate EUI, which in practice is the base of how I approach it in my role. I'm looking at the campus, and I'm going to saving 2% on a high energy use building is going to be equivalent in impact to saving 10% on a low impact building. Also, buildings that run all the time and are high energy users, you make one small change and they can have a lot of energy. So these are the things you can notice, right? from looking at those data. So, I think this is a good stack in how we've approached it. I mean, um, when Gabe and I first worked, we were in the base of the pyramid working our way up. And
Yeah.
now we're kind of working our way up the pyramid as technology advances. So, but it's also rebirthing too, because you get new space and equipment that was cutting edge and helped you out and becomes legacy. And you need to improve it, or it becomes stuff that we used 15 years ago isn't as easily usable, right? As systems update. It's another piece, I don't want to go into details, but the migration of ITS, which is the linchpin of this work, can really have cascading impacts on your technology.
Sure. And centralizing the access to the building automation system. Like, do you, Patrick, at Santa Cruz, do you have like a centralized remote front end for all of your buildings that someone can access, or do you have still some disparate control systems throughout?
For the most part, yes, centralized system. But as an example, as ITS rolls out new security controls, then we start having limited access to that data, at least from, like, in our example, SkySpark, right?
Yeah.
That's why I brought it up. You can have new technology security issues that you must update or you lose access. It's a functional real thing. Because it's such an evolving space, right? You really need
Mhm.
to keep evolving, which means investing time and
Yep.
money.
Yep. Gabe, what about you? Are you guys building off of a similar pyramid? Like, does this resonate?
Oh yeah, absolutely. And I think, like Patrick mentioned, it's that base. That was the first thing. When I started working at UC Santa Cruz almost 20 years ago, I was mainly controls. I didn't know anything about energy. Patrick was my mentor for energy. I didn't understand any of the terminology or any of it, and that was the number one thing when we started retrofitting buildings. Is he would say we need meters, and I'd say okay, let's go put meters in. And so we put meters in and automate them and bring them into the database. And but it taught me that that's the basis. We got to have a way to measure, and that's really where you have to start at. And then from there you can kind of build up. You build up your
Yeah.
automation, and you start building on the more advanced things.
One quick detour on that point is, talking about bringing in meters and sub metering is something we obviously cover a lot. I have heard this hot take that, like, especially around buildings that were trying to achieve LEED certification, there's a level of submetering that occurred over the last decade or so that was like kind of overkill for some people, and they've got submeters that are doing, they can't keep track of them. They don't even know if the data is accurate anymore. So I don't know. Any thoughts on that, or advice for somebody who's less far along on like how much is too much or not enough?
There's a balance. You need to understand, like, the resolution, right? And it's case dependent, right? So the problem, a lot of it is the code, and LEED and Title 24 are prescriptive, and without the understanding of why those exist, you can end up misappropriating
Yep.
that to get the points or meet the code, and that can be as harmful too, because then the more you add, the more you have to maintain, the more you have to upgrade. And a lot of times it's understanding, oh, we have VFDs. That is a meter, right? It's just about specifying it correctly. We have a chiller. Let's make sure to put a Modbus card or a BACnet IP card in so we can get all the data that's available, because that's a meter too, right? Because
Hmm.
it's really just tracking points that impact energy usage. That's all a meter is, right? So it's really, sometimes that happens from either point chasing, which will happen on projects. There's chasing points without understanding of the reason, or misapplication without the understanding of code.
Totally agree. Okay, let's move on to this third step here. We covered some of this. I'll still mention it. After you have looked at your energy management hierarchy of needs, you have to audit your HVAC controls infrastructure, which is related but a little more in depth. That means, where do your controls live? So Patrick, we were just talking about how you guys more or less have one front end, one remote area that people can access. Is it cloud? Is it local? Is IT letting people access it remotely? All those questions. What are your controls doing? So I don't think we've yet mentioned ASHRAE guideline 36, which we could get into as like a common, standard that people are using to try to achieve good energy sequences throughout their buildings. Do you have that, or do you have something else? What are these sequences written based on? Was it the design engineer's original sequence? Did a energy audit company come in and change them 5 years ago? Where are you at? And then who updates these today, and how do they update them? This is just kind of like taking an inventory of like, if I were going to make a change, where does it change? What am I changing, and who is actually able to change it? And I guess my question for you guys is, I'm curious how difficult this is for you to get a grasp of in your campuses, and I'm thinking that it might be a little less difficult than other verticals. Like, for example, Amazon gave a presentation at NexusCon last year about their fulfillment centers, and they said this was one of the hardest things to do. But I think a lot of that is because they have fulfillment centers over the entire North America. So the building automation system in the one in Seattle is probably has nothing to do with the building automation system or cloud connection in the one in Miami. So they think this is really hard. I think you guys as campus owners have a little bit more control over it. But what do you think? Do you feel like you have a good sense of your HVAC controls infrastructure and who has access to these things and how they update them today?
I mean, yes and no. It's a little challenging. I mean, we are a campus, but our campus is spread all over San Francisco and Oakland
Mm-hmm.
now, and so trying to track down what we have out there is challenging. I mean, we have I think I early on when I worked at I was on the campus at UCSF for a while, and we worked with IT, and we developed a really good relationship. This was probably 10 plus years ago now. And we were able to build out our VLAN and get IT support and start going to IP-based controllers. I think we were one of the first in the nations really to push it out widespread. And so we were able to learn how to get access to our systems and be secure about it. And so I think we have good visibility for everything that we have out there. Through the time that I've been here, I've been trying to track down all the different control systems we have. So I think we have a pretty good catalog of everything out there. So it's a process though. It's not easy. I think the age of our infrastructure makes it a challenge, but I think we are working through it. I think we have a pretty good idea of what we have.
Yeah. Patrick, what about like who has access to actually change these things? Like, do you guys have strict guidelines around who's actually able to go into a sequence and update it and tune it, and empowering the right people yet not risking giving somebody too much access that they can hurt things?
Yeah, that's the balance, right? That's I lean on our controls department and our HVAC department. We don't implement the sequences. Back to how Gabe and I know each other, that was such an important partnership because I couldn't do the work without him. He was the one with the ideas and the technical knowledge and the access to implement. And what we did is we traded, he says mentor, but we really just traded knowledge. And together we were able to do a lot of stuff. And I bring that up because that's so important. I know he's doing that in his role now, and it changes over time. Sometimes it can just be understanding how to get the funding, which is basically understand the savings, the benefit, right? So a lot of the work, the economic work, I can fall into that role, and that's what my role still is on the campus. So it's about for me, I always say energy management's change management because you have to be encourage people to make changes, which by nature most people are change averse and risk averse, and so it takes the ability to be able to take that risk. And Gabe has that characteristic, which is why he's successful what he does. I'm trying to encourage that characteristic when I'm dealing with our controls folks, so that they will make those changes because that's the way it works. We recommend, we identify, and we collaborate with the technical team that's implementing it. I have an understanding of it. I know the wire sheets. I don't make the changes, so that helps because I can come with a more educated input. But that's an important partnership to have, whether it's you and your other technical staff, or in the case of other campuses, you're working with your contractors and your partners or your consultants, right?
Yeah. It's such a cultural thing to build a culture of like wanting to optimize your equipment, because as a former controls technician, like going into a central plant and changing the tuning on a PID loop, or there's some set point in some pharmaceutical room that you don't think should be overridden, but you're not quite sure why it was in the first place. Like, that stuff is nerve-wracking to change. But it seems like you got to really build this culture around people who are trained to do the right thing and empowered to make those changes, so you're not leaving
And
energy
this
on the
is the
table.
key thing. The default setting is if I do what they've always told me to do, then I won't get in trouble or be critiqued, even though that could be punishing or making the equipment more vulnerable to all those things, right?
Yep, love it.
That's the mentality switch. It's the impact of not making a decision, right?
Hmm.
And so that's what I'm always preaching to. And even and it's hard because I'm not the one making the decision to take the leadership to go, we need to do this because not doing it's costing the campus
Yep,
and potentially has all those fears that doing that control point change will have, right?
completely agree. All right. The fourth step in the setup phase is designing the pilot, which I'm going to kind of skip because designing the pilot is designing everything we're about to talk about in phase two, which you guys have all done some of this. So I think we can go past that, but just know that if you're at step four and you're you're following along, that is designing the next five steps we're going to talk about. So the first step in the pilot phase is really like where the rubber meets the road of optimization. And that's, I couldn't find a better way to write it than deploying the optimization process, because there's so many different things that you can do. And I'm trying to have you guys help me really bring this down to some like real world examples for the audience. Like Gabe, you mentioned, schedule changes as a good starting point. That is something you can actually do. Um, Going in and updating, tuning loops or updating set points, that's something you can actually do. Um, I talked a little bit about advanced supervisory control. I'd like to know if you guys are experimenting at all with that. But like, what are the examples of like the real things that you guys are seeing done in these buildings optimizationally that's actually moving the needle and saving energy?
Yeah, I mean, I can speak on this. I mean, I think, like I mentioned, scheduling is a huge factor. I mean, I think
Hmm.
I know it seems like it's such a simple thing and probably the most unsexy thing, but it'll save you. It is probably the biggest saver. I learned this early on, like with the work that Patrick and I were doing. Um, part of the mandate that he would give me is, okay, go replace all the controls. So we did all the work in house, and so we did everything from scratch. We built the panels, control work, and he told me just program it how it was originally designed. So that was what we first did. So we replaced the controls, program it to the original design, and then he'd do a measurement. We always would find out that we would save, our biggest savings were there. We hit 10, 15, 20% just off that. And you would think, well, how is that possible? You didn't change any sequencing, operate. Well, it was scheduling. We gained visibility of the buildings. We didn't have visibility before. Visibility was a little, desktop sitting under somebody's desk, and then we brought it on the web, and everybody can see what's going on. So it came down to me was scheduling. That was such a huge factor. So that is the first thing we look at is scheduling. Have the buildings did somebody go in and change the schedules?
Hmm.
and it just inevitably it's happened, and we have to go and figure out why it's happening. So again, not a very technical thing to talk about, but I'll keep going back to that as that. I think if do one thing, just go through your schedules and you'll be surprised what you can find.
That's great. Patrick, what about you?
Oh yeah, scheduling definitely huge. But I'll give Gabe more credit. Like I've watched products roll out. Who's the last person in there, and the one who's getting pushed out the quickest? The controls people, right? So a lot of times these buildings just get buttoned up, and they were never meeting design, especially the older ones. Now there's tools to do that. So when Gabe did that work, I'd go farther and say it was scheduling. He implemented the design the sequence as designed, which probably was better than how it was left.
Yeah.
And it also cleans up all the hot and cold calls and quick fixes people made because they need to get on to the next work order. And this is just all I've heard. Sometimes like you just got to resolve the issue and make that faculty stop calling the dean, right? And so that builds up over time. And so just doing a wipe, clean, and restart, which is kind of what he did. We had an Earth Marine Science building that it was tremendous. The demand savings just from implementing its design. But scheduling and cleaning, I've noticed now working with the team we have now. A lot of times um, these buildings are living organisms. So they put a new wing in, they update, they add new equipment, but they don't renovate the whole space. They don't revisit the whole sequence. They just tune it for the new absorber or whatever. and and those projects add up over time. You just need to go in and take a look at it again, and you see it in these sequences, these wire sheets. They've just been revved and revved and revved. Sometimes you just need to go in and start over. So that's the work we're doing now. The other piece is just sensor failure. SkySpark is what we're using. That was the first thing that popped up, was just like sensor failures, um,
Mm.
and this comes down to simple things like, hey, maybe it's, even though it costs 5 times as much, we should specify better equipment, because you're paying someone $100, $200 an hour to get up there and make that fix, and that's not even counting the energy penalty. So those are the simple things. But honestly, day one, scheduling. Campuses are variable schedule. They don't fit into those boxes of weekly schedules and holidays. They have tons of holidays, and that's not even counting the simple stuff. All right, we have a break between quarters. That means the students are gone, but the staff are there. Okay, it's summer break. The students are gone, but the staff are there, right? Um,
Mm.
or Thanksgiving. Some of the students are here. The staff are gone, right? These are living organisms, right? And so scheduling and maintenance of your scheduling is huge.
So take that one step further for me, either of you, but scheduling's huge. You guys are working on making that effective nonstop. You're using, like you said, Patrick, just like the known schedule of the building. Like, is there classes today? Is it a break? Is anyone planning to be there? Are you also using any other sources rather than just like the plan schedule for the building? Are you using occupancy sensors, access control, badge swipe data? I don't know, anything fancy like that to help with when it's on and when it's off?
Not yet. We're definitely, if you have an isolated space, there was a project that was worked on years ago that Gabe and I worked on. It was called, demand control ventilation, but it was more than that. I called it demand-based scheduling, right? Using occupancy sensors and CO2 in a piece of equipment that, like controls a certain space, like a lecture hall, right? And then you don't have to worry about updating every quarter with the academic schedule, because there's a class from 3 to 5. This quarter, next quarter, it's 2 to 3. If the CO2 is fine and the occupancy, not just reduce to the minimum ventilation rates for volatiles, let's turn it off. And people would be concerned about that, but my argument was, well, the janitor's there at 2 in the morning and the system's off, right? So it's safe,
Yeah,
right? You've
yeah,
got because that's the number one. People are always coming up with reasons why you shouldn't do this stuff,
yeah.
but that's the only thing we've done. We've been looking at the data you're talking about, which is I know the Pelican system, I guess, where you can use your lighting and your HVAC together, either HVAC informing lighting HVAC, or now they're talking Wi-Fi data. That's something we've been
Yep.
talking about, but we haven't functionally implemented that yet.
Okay. Gabe, what about you guys?
I mean, for here, healthcare is a little trickier, because I think because of what we're serving, and you got patients, and you have surgery centers, operating rooms, pharmacy. So getting into that level where you can, shut things down. We have to, there's a lot of caution to it. We have been doing scheduling for operating rooms, shutting down at night for a certain amount of operating rooms. So that's been a huge energy savings that we've found. I know when I was at Stanford, we were deploying where we connected right directly to the the scheduling system for rooms. So for like auditoriums, classrooms, things like that. So we were able to manage on off times for zones, to that level. And I think we were able to drive quite a bit of savings through that. So I think there are a lot of means out there. I think, like what Patrick mentioned, I think some of the newer stuff is the Wi-Fi and Bluetooth and
Yep.
things like that. I think there's a lot of promise in those areas for doing some advanced scheduling.
Yeah, definitely. All right, I'm going to keep moving us along. The next one is measurement and verification, which is you're answering the basic question of, did the optimization produce the outcomes that you committed to? I think we can go past this one unless you guys have anything to add. We did talk about it a little bit when we were talking about the hierarchy of needs and the balance of the amount of metering you need versus not. But really, if you're doing this for the first time, you just deployed some optimization process and you need to now go check and prove that it actually did what you expected. Step 7 then is testing and adjusting roles. We haven't talked about roles as much, so I do want to get into this one. This was hard to put together because there's like no prescription of the exact roles that you need to have an energy management program that focuses on HVAC optimization. I came up with 4 people who are always involved, and these could be like the same person, right? Maybe one person is doing all 4 of these. Maybe it's 4 different people. Maybe it's 2. But there's always the program champion. That's the one common thread. That's the person who actually cares about this, whether it's because their job mandates them to, or because they're just passionate about energy savings. One of those things. You two are probably the program champions for your facilities. The second is the optimization opportunity finder and validator. So that could be a person or a technology, but who is like going and saying that's what's using the most energy and there's a way to fix it and this is how we would do it. And then after that happens, that proving that it actually worked. And that could be related to the controls and automation team. But at the end of the day, if you've got your 3S's, schedules, sequences, and set points, somebody on that controls team is actually typing in to change those things. And then finally, the facility manager or building operator. If that's not the same as the people above, those people care about comfort. And if you're going in and optimizing a building when they're responsible for the comfort of it, you guys are going to interact for sure, and got to make sure that you're going in the same direction. So my question to you, Patrick, you can maybe answer first is who are the main, like the key roles would you say on your team that are enabling this HVAC optimization, whether it's internal or external? Like who are the key people? What are they doing?
Yeah, it made me think about this. So I always think of it as technical, economical, financial, and leadership, right? So technical, you need someone who can make the changes, be it replacing sensors, changing operations, and these all overlap too, right? Implementing these sequences and making these changes to operations and maintenance. Then you have like the technical, economical. That's energy in our team, right? Um, Using technology to identify, like in our case, Sparks, SkySpark, fault analytics, attaching the economic benefits of that because
Yeah.
understanding what you can do and how it's going to save you from a sustainability perspective, but from a money perspective. You've saved money, everybody's on board, right? And that can be, understanding how to measure it too. And then you've got the financial, you've got the people with the money and the resources to really do the work, right? To prioritize the work to get it funded. And then you need, leadership.
Mm-hmm.
So those are the big components. When you have all 4 components of those, you are humming along, right? And Gabe and I had that. Like him and I worked on it, and we had the financial and we had the leadership, right? Um, when you don't have one of those, or one of them's not as supportive as it could be, then things stall. But those are the big ones.
Did you guys have at times when you were working together that like you were fighting for justification of the program? And I don't mean program as in like obviously you need operations and maintenance, but like it takes like you were saying, Patrick, leadership to see the value in putting extra effort into optimization and energy savings. Like was that always? I mean, I'm sure there's been times in your career where it wasn't as smooth, right? Has there been times where
Oh
you're
no,
working?
it was an amazing time. We had a lot of liberty to do work. I
That's
mean,
great.
and combined with we both had the right skills to get the work done. And I leaned on Gabe's skill a lot, but I was just like, show me the projects, I'll figure it out. I'll submit, and I'll evaluate, I'll get the money, and the money was available.
Yeah.
And the basis was the loan payment would be less than the energy savings.
Yeah.
So, and we were looking at a campus that hadn't been addressed in a long time, which meant there was opportunities abound.
Mm-hmm.
And it hadn't been maintained in a while, right? So that's when you're starting out this, it actually can be a great time because I won't use the cliches anymore, but the opportunities can be easy to find and they're very beneficial.
Yeah.
As you wind down, you're looking deeper. And also, as these programs mature, people start critiquing and evaluating them. So the money doesn't free up. It's just like the nature of a program. Early on, it's usually easier. As they refine it, it gets more difficult.
Yeah. The other thing there too is that if you're going in and everyone knows you're doing all this optimization work, what a perfect scapegoat for any issues, right? Like, oh, now we got these issues over here. Oh, it's probably Gabe who was doing this optimization work who changed something who caused this. Like, I heard that a lot looking through our content that's covered this is like, it's a scapegoat. You're changing things to try to save energy. So what an easy
That can
finger
work
to point.
against you too. That can
Yeah.
work against you too because the utility rates can go, well, you saved energy, but why did my bill go up?
Yep.
It's a double-edged sword, but yeah, you can get you can get extra credit or extra critique.
Yeah, exactly. So in your example of when you two were working together, I would call you, Patrick, probably the program champion who was keeping this thing moving, and Gabe was the optimization opportunity finder, validator, and probably the controls automation team as well, who was going in and doing this stuff. So that's cool. Uh, Gabe, what about at your current role at UCSF? What are these? Do these roles resonate? Is this what you're seeing?
Yeah, I mean, I think, I mean, I'll key on the program champion is probably the key. I mean, you have to have that, right? And it could be champion of champions, right? There could be multiple
Hmm.
people, it could be a team. It just made me think how sometimes I've noticed this over the years because you start being around enough, you start noticing patterns, and you may see somebody like at Nexus Con who's with an organization and they're the program champion and they're up there and they're talking about all these energy savings. Then the next year they're not there, and then I look around and I'm like, what happened to this person? Well, they changed to a different company, and then you never see that other company anymore, right? They were the program champions, and now the whole program has
Yep.
died. So the program champion is huge, right? You have to have one person or persons who are going to believe this, push it, and really work hard at it, because it is challenging. I mean, I think, like Patrick mentioned, yeah, it was really good for a time. I do remember, I did have some pushback in the very beginning because I was like, hey, I'm going to rip out all the controls for this engineering building, and we're going to put all new controls, and it's going to work better. And then, obviously, you have people saying, "What are you? That's crazy. What are you talking? You're going to rip out all the controls? You're not a controls person. You're not a controls company." But then after we did one or two projects, then I think we proved ourselves. And so, after that it went well. But I face those challenges now here. But anyways, but yeah, I think going back to the program champion is the key. You got to have that one person or persons.
Yep, exactly. Okay, we'll keep rolling. The last step in the pilot phase is evaluating the optimization pilot. I'll skip over this piece, but if you were new to this, you just did all these things, and now you're evaluating whether it worked or not so that you can either try to scale that thing you did or go try to understand what didn't go right and potentially do another pilot. That's explained within the playbook. And now going into phase three, the rollout phase. Standardize before scaling. We've kind of talked about this. I don't know if you guys have anything to add here, but I think what really is key here is like, how are you actually controlling who is optimizing sequences? And we already kind of talked about the culture of people who are empowered to do this. Maybe one thing that we haven't touched on, or anything else you guys want to add to standardizing, is anything you can say about commanded points. Maybe one of you mentioned earlier that it's commanded for a certain amount of time, but I'm an operator. I got a hot call. I just need this person to not be upset. They're an important person. So I command that thing way cool, like this is going to work. And then I go do the 75 other things I need to do and forget about it. And like, how do you avoid that? That seems like the situation that always would come back up over and over again.
Yeah, I think that is probably one of the most difficult challenges. At least I found over the years. I mean, we've implemented, in some control systems front ends, you can implement a time period where it can't be permanent. But I've received a lot of pushback on that too. Facility people
Right.
hate it. They do not want it. They will fight you on it as much as they can.
Because
So
that's kind of scary too, because then it's just going to release who's knows when, and like
yeah,
stuff's going to
yeah.
come back. Yeah.
So yeah, it is challenging, and so often, like, if we're doing the graphics internally or upgrading them, it is that choice, right? Do you make this point visible or do you hide it? There's things you can do. So it is a hot button issue, and it's but I think it is key because, again, as we're talking about, these overrides can kill energy and kill good operation of the system. So I think is one of those things that I think every person has to kind of figure out and address with the facility team.
Yep. Okay.
Yeah, on our side, on the energy management side, we're using our fault analytics or Spark, Sky Spark, to. We can't stop them from doing that because that's a different group, but we can set up rules to identify when that's being done,
Yep.
right? So mitigate it, right? Because before it would be in blind. But yeah, it's the technological whack-a-mole.
Yeah, exactly.
It really
That's a good
is.
term for it. All right. So that was step 9, standardizing. Step 10 is scaling the roles. We just talked about the roles, so I'm not going to dive back into this here, but that would be if you've got a distributed portfolio or just more buildings than you can cover with your internal team. How do you take that program champion, that opportunity finder and validator, and make sure that you have that everywhere that you need it? And then planning the expansion waves. So maybe we'll hit on this one quickly. You know, we're picturing this, we're talking about this hypothetical situation where somebody started optimization, they planned this pilot, they did it, it was great, they want to repeat it, they're standardizing, and now they're going to do these expansion waves. I think you guys probably do some form of this, even if you don't think about it this way. But you guys have buildings that are all sorts of different levels of maturity. So we talked about it, but I'd like to hit on it again. Like, how are you addressing the energy consumption of the new construction project that's happening on one side of the block to the building that has outdated digital controls on the other side of the block, and like managing those two projects that are in totally different life cycles at the same time, and what energy optimization that they need?
I don't know if there's any clear answer to that. I think because we have buildings that are new, and then we have buildings that go back 80, 90 years, where we have pneumatic or we have control systems that are already legacy, no longer available. So it gets it is a challenge. I mean, you do the best you can. You do the best with what you have, and I think that's the key part of it. Is you have to look at what's there, and you have to be able to determine the most that you can expect out of any system, and then just hope to achieve that. With the newer
Yeah,
controls, obviously you can get to 100%, really good optimization. With the old stuff, you're going to be limited. So I think you just have to temper your expectations and just do the best you can with what you have.
sure. I think that the prioritization, Patrick, that you said earlier is pretty important here. Of like, if you have a building that's a huge energy user, optimizing 2% there might be a lot more valuable than a building that doesn't even matter, but or doesn't even matter. I mean, doesn't use much energy, but you're optimizing like 25%. You got to kind of prioritize how valuable it is to the portfolio.
Yeah, you make practical choices, right? So buildings that where you can do a lot of stuff, you try to do stuff. But the one example I'll talk about is we had this old lab building, which for every time I tried to do projects that are like, oh, don't touch that building, we're going to knock it down. After 15 years of hearing that, I was like, they're not going to knock this building down. So, but we couldn't go in and we didn't, these products like this, what commissioning is not going to work. So we do simple stuff. Like what we did is said, oh, well, let's modernize its air changes per hour, because it probably is still doing air changes per hour based on when it was built. So we can do simple stuff like putting VFDs on exhaust and supply, and just keep it simple, right? Updating old buildings to modern requirements, right? So those are the type of things you look for, those simple. And like you mentioned, it's a 24/7 building. So, and happy to say that we, after being told for 15 years not to do anything, 12 years later, that building is still not knocked down and saving all that energy. So you kind of make to kind of you approach functional things you can do based on the technology, because a lot of times this work's not going to justify a full project. I can, right, especially in lab and science buildings. But the thing that Gabe and I both share is the climate we're in, which is amazing and beautiful. But when you're trying to retrofit a lab building in San Francisco or Santa Cruz versus one in the central coast of California, where it's seeing like 110-degree days, that can have huge financial impacts in that, because of the climate region it's in, right? We're at 55 degrees half the year, literally, which is great for energy use, but hard for projects.
Yeah, sure. All right. The last step is step 12, sustaining the program. Gabe, I think you already kind of covered this with your example of there's a program champion at NexusCon, and then they switch companies, and then you never hear from that other company again. That tied also to, you do this big retro commissioning effort. Maybe you hire some energy auditor to do it, and things are great. Well, of course you're going to just ignore those buildings for the next who knows when. So I think that sustaining the program is specifically hard for this playbook, because once you run it, like, everybody wants to forget about it, but then in 2, 3, 4 years you're going to be in the same exact spot. So a mature program is one that can be sustained even when that champion leaves your company, and that means that you've got some actual integrated standards in there. Okay, so last question related to kind of this playbook that I want to ask you guys. It's just kind of more what's going on in your world. Uh, Not to push on the spot, but what is like a next on the horizon related to optimization that you're trying to do with your buildings, whether it's installing a new technology or a new building that you're trying to address? What's something that you're kind of just getting started on your campus that's on the horizon that you're working on?
Let me think. I mean, well, I don't know if I want to go this way, but um, I am working on, well, this idea about keeping buildings from drifting. Um, I am working on this idea of using agentic AI as a way to monitor the building. So we're currently building something in house to kind of address that. I don't know if that's too much farther too far out there, but I think it's very doable. I think the technology's here. I think it is very doable now, and I think it could. I can see the industry shifting in this pattern of how is AI going to help us? And I think people are still trying to answer that question. Well, I think this being able to keep a building from drifting, I think is probably really a good example of how it can help us. Because it can be able to monitor temperature points and monitor key indicators to determine if a building is losing, its energy, its EY goals. So it's something that we're working on right now. We're hoping to have it deployed within the next few months. So I think it's something I'm excited about, and hopefully to see how it turns out.
Yeah, and I do recall that Gabe has submitted an abstract to present on that exact AI agent topic at NexusCon. So if that part sounded interesting to you, you should probably come see if Gabe's talking about it in Detroit in October. All right, Patrick, what about you?
I mean, there's so many things I'm working on related to this topic. The one thing I've been thinking about is really, uh, since there's limited, usually the biggest pushback you hear is at least I hear, is that sounds great, we should do this, but we have too much space and we already don't have enough people and money. So revisiting, the one comment I heard back from one of our supervisors, I said, how much do you spend a week on staff time doing planned maintenance? And they said 30 to 50% of their time is spent on planned maintenance. So why not use analytics and AI? I didn't think about AI until Gabe mentioned this. I thought about analytics so that we can convert some of those old routine scheduling. Everybody talks about the filters and the DP and stuff, but how can we expand out? Maybe tracking the performance of a motor so that we know when its efficiency drops, rather than just someone goes out and just reads the numbers on it, puts a logger on it, and burns up time, right? How can we modernize the efficiency of their time to free them up to do this work, right? So that's the thing I'm working on right
It's
now.
great. Cool. Yep, that seems to be a common one. People are getting AI into their work order systems to see if they can save time everywhere. So it's a code that I don't think anyone's totally cracked yet, but a lot of people right there. So okay, cool. Um, the end of the playbook is maturity framework. I'm going to leave this as a teaser for anyone who's listening because we're short on time. But basically, we've developed a 5-step like grade yourself system, and you can look at it in the playbook. But also during the Nexus Cast virtual event on June 17th, where we're going through this, we're going to do a live poll of the building owner audience, which will be couple hundred building owners, and then we put the results of those poll on the board and see where people are at with this process. We did this with condition-based maintenance, and at our last event, and I think uh, uh, 70 to 80% of the building owners who were present admitted that they were either a level 1 or 2 on a scale to 5. So they're like, we haven't figured this out yet. We're trying to. So there's plenty of work to do there. I'll be very curious to see if people feel the same way about their maturity with this subject. All right. Well, this has been great. We're going to end, as we always do on this podcast, with carve outs. So it's a total change of mindset compared to what we were talking about. This is just something fun that's been going on in your life, something you want to share with our audience. I'll go first. I was going to talk about a book, but I'm changing my mind. I'm actually doing something pretty cool this weekend. I like to run. It's my hobby. I'm not fast, but I like to run. And I am doing this event called Ragnar this weekend, where there's 8 of us. We're going to Aspen, Colorado, and we have to run, I think, you have to run 3 different legs. It's a relay, and each person runs 3 legs. So that's 24 total legs. But all in all, I think I run like 13 miles, like 3, then 5, then 7, or something like that. And it's all through the trails of Aspen, but it's just continuous. So it's going to take us like 24 hours or 30 hours. And so you could be running through the middle of the Rocky Mountains in the middle of the night just with your flashlight. So it's a little exhilarating, yet it's, still running, which is boring to most people, but I'm looking forward to it. So it'll be fun. Gabe, what do you have to share?
Yeah, so mine is probably like the opposite end of what you're doing. I've been into making pizza. That's my latest
Oh,
thing.
nice.
My daughter was telling me, "Hey, make homemade pizza dough. It's really easy to do." And she kept bugging me about doing it. So finally, I did it, and I was like, "This is fantastic." So then I went into this deep dive of pizza dough, and I'm learned how to do like cold fermentation, 2-day cold fermentation. I got a pizza
Sweet.
oven outside, and I can't get enough of doing it. It's so much fun, and it's delicious, and it's not running, but still
That's
it's
awesome.
good.
Hey, I love it. So are you using like the dry yeast that you can buy at the grocery store, or where are you getting that?
No, it's just basic yeast, but it's more the process. So
Okay.
it's like you do a starter, and then the next day you do the dough, and then you
Yeah.
cold ferment it. You leave it in the refrigerator for 2 days, and it's supposed to help enhance the flavor of the dough and all this fancy stuff. But it's a lot of
Love it.
fun. People love it. They come over. It's easy to make.
Yeah.
Yeah, it's a fun thing to do.
That's great. All right, Patrick, what about you?
There's a few things I thought about, but I guess what I've been doing for the last few years is doing triathlon. So I've been doing Ironman and half
Nice.
Ironmans. The last 3 years, I've done 5 half Ironmans and 2 full Ironmans. So it's taught me a lot about how much time you can spend each day working out. But it's been a good thing to do. My goal is to qualify for Ironman Hawaii, which
Cool.
is a very very tough goal. But I'll bring up what's interesting. I've been reading a lot of books or listening to a lot of books because I'm on the bike a lot. And Rick Rubin's book, The Creative Act, is so good
Okay.
because he talks basically about how we all have the gift of creativity, whether we're writing a new song or inventing a new sandwich or a new pizza. The creative act is within us all to do what we're doing. And this work is about everything we've talked about is kind of exemplifying what she's talking about, which is tapping in to what your work is in life and how you can do the creative act with it. Really inspirational, really good stuff.
I love that. That's a great one to end on. So, all right, thank you everyone for coming.
Okay, friends, thank you for listening to this episode. As we continue to grow our global community of changemakers, we need your help. For the next couple of months, we're challenging our listeners to share a link to their favorite Nexus episode on LinkedIn with a short post about why you listen. It would really, really help us out. Make sure to tag us in the post so we can see it. Have a good one.